So that brings us to another vocabulary word called the heat of vaporization. You will see the heat of vaporization symbolized as an H, which stands for a term called enthalpy, and then it'll have a little subscript of vape. So that is your heat of vaporization. Now, what that is, it's the amount of heat energy needed to boil 1 gram of a liquid. So you knew we were getting to that because if we can plot those boiling points, we can also figure out how much energy is needed to boil off 1 gram, and therefore we can know how much heat is needed to put into a substance of various weights and masses. So your heat of vaporization is going to be a constant number that is dependent on the substance. So for water here, we see the heat of vaporization is 2,260 joules per gram. Now a joule, with the J there, a joule with a big J, is the unit we measure energy in. So whenever you see a joule, it is telling you we are measuring the energy. Okay, so joules is a base unit. Remember, we have a two-dimensional unit here, joules in the numerator, grams in the denominator. So remember, that is just a conversion factor. So what that means is that it takes 2,260 joules for every 1 gram of water. All right, so we can use that now to solve some problems. All right, so in order to calculate the heat energy in joules needed or the amount of energy to be removed, we can use the equation Q. That little Q right there stands for our heat energy. Okay, heat energy. And the heat energy is measured in joules. All right, the M stands for your mass in grams, and then the heat of vaporization, which is going to be a given. It is your conversion factor, and it is specific to the substance you are analyzing.